Hi everyone, I am Denis Janot, Director of Field Engineering at solo.io in EMEA, and I'm going to speak about Istio locality and latency based failover with Gloo Mesh and WebAssembly. So first of all, like what is Gloo Mesh? It's a management plane that sits on top of multiple Istio control plane and makes your life easier by giving you visibility about what's going on across all the different services running in these different Istio clusters. It helps you to configure multi-cluster traffic, to um, get like WebAssembly filters deployed, like doing many things, right? But here I will really focus on some of its capability. So WASM on one side, the way we consolidate all the metrics in one place, and the failover routing that we can configure easily with Gloo Mesh. So we'll do like two different scenarios. One which is what we call locality based failover, which means that if you cannot reach a service in your local cluster, you try to find the same service in another cluster in the same zone, if you cannot in the same region, if you cannot anywhere, and everything automatically. So let's say here I have like three clusters, a management plane where I have Gloo Mesh running. Then I have like two clusters where I have Istio deployed, one with the book info, but everything apart from the v3 version of the review service, and the second cluster everything, including the v3 version. So what Gloo Mesh does is that it's allows you to configure this failover. So if I cannot contact, the product page cannot contact reviews on cluster 1, then it will automatically goes and contact it on cluster 2. And to do that, we have this concept of a virtual destination, and you can see this example here, the YAML. It's very easy to configure. You say, okay, I want to set a new host name called reviews.global, and it is backed by all my reviews service running across all my clusters. And it's localized. That means that it will always try to use the local instance, but there is an outlier detection configured. So here you specify when do I want to fail over, right? So if I have here at least one error, then I want to have like 100% of the request going to the other cluster, and after like 2 minutes, if I can contact normally the local one, I will just fall back automatically. So here what I show is like it's very easy to configure, you see, with this YAML. And behind the scene, what Gloo Mesh does is that it will take this simple virtual destination YAML, and from it will create multiple Istio objects to make it happen. So it doesn't modify Istio, it just like configure Istio with a lot of different objects to make that happen. So for that you need like a destination rule where you see something similar to the outer detection that we configured here. You need like a service entry for this reviews.global name that contain all the possible endpoints. So the local review services with the pod IP, and the remote ones with the IP of the gateway to contact them, and the information about the region and the zone and so on, so that Envoy can decide where to send the request, because Istio will take this service entry and will then translate that into Envoy configuration that will let Envoy decide when to do the failover. We also need some special things like renaming the host name in the second cluster when the request arrives in the gateway, and having a destination rule there as well, having also a service entry there with the local IPs. So you see like a lot of different things that would be very difficult to configure by yourself and to maintain. So Gloo Mesh makes it really easy. And then you could decide, my application will now contact reviews.global. So the product page, I will update the product page to contact reviews.global. Or you can make it transparent. You just create what we call a traffic policy, and you say, okay, if I have a request going to reviews, I want to go to this virtual destination. So I want to go to reviews.global, and it becomes transparent. So like as I said, very easy to implement, and even if generally you try to use like these different glue mesh objects because they are very easy to use, you can still, if you wish, like create a traditional Istio virtual service and target this reviews.global hostname, and you would get like the benefits of this virtual destination. So let's see that in practice. So what we will do here is that I am going to create these two objects we spoke about, right? So I'm going to create this virtual destination first, and then I'm going to create this traffic policy to redirect the traffic, to send the traffic. Instead of saying to review, you send to reviews.global. And if I go into my environment now, what you will see is that when I refresh my page, I get either V1, which is no reviews, or V2, which is like the black stars. And V3 is red stars. I don't get it because currently all my requests are going local and everything works fine. So what I'm going to do now, I'm going to patch the deployment of the review service locally to replace the command. Instead of receiving the request and responding to that, it will just sleep for 20 hours, right? So it will not reply anymore to the request it receives. And if I continue to refresh here, you see very quickly I am able to continue to have my application working. It will just spread across the version because I didn't specify anything in terms of which version I want to use, but there is a way you can check that it's really going to the second cluster. Is like looking at the logs of the review service in the second cluster. So I am in the second cluster here. If I refresh here, you will see the request coming there, right? So pretty easy, very useful locality based failover, and you basically it really provide like more availability, right? So that was like the first thing, which is like out of the box and very interesting in Gloo Mesh. Now you have other components that I will speak about that are the foundation that I need to be able to provide this latency based failover, not locality based but latency based. So first of all, in Gloo Mesh, you have this global observability piece. So you can go in the UI and see, whenever you create a policy, like a security policy or a traffic policy or whatever, you can see what are all the services running across all my clusters that match the criteria I have defined, which is very useful. But also, you have the ability to get access log on demand. So you can say, okay, now I want to debug a problem with the review service. I would create this access log record targeting all the review service across all my clusters. And you will start to get very detailed access logs for all the communication to this service. You can see here is just like a small portion of it, but you can see in the access log the identity of the source, like the SPIFFE ID, the identity of the destination. You can see metrics. You can see if you have a 503, like, which is the thing that you try to debug very often in Istio, right? You get like the response flags with all the details of the name of the response flag. I think I will do like a video just on that because it's a really interesting topic. But what I will really leverage here is these metrics that we consolidate. So basically, each Istio cluster has the Gloo Mesh agent, and the Gloo Mesh agent gets all the metrics from all the different pods and pass this information to the management plane. And we have Prometheus running here, and we have all these metrics in one place. And then we build some graphs that allows you to see what's going on, right? And that means that if I want latency based failover, I need to get metrics, right? And the good thing with Gloo Mesh, I have the metrics in one place for all my clusters. So I don't need to think about, which Prometheus instance I want to use, right? Because if you say I want to do, I don't know, compare the latency between different clusters to decide where to send the request, for example, then you would need to go to multiple Prometheus instance. But here we have everything consolidated in one place, and you can see it here. Basically, you see, like, based on what I did before, we can see some traffic from the gateway to the product page, from the product page to v1 and v2 of reviews, and even like going to the other cluster, right? So it's just like depending on the time frame you put and so on. But the idea that really you get like all these metrics in one place, and that's what we are going to leverage. And we have everything stored in Prometheus, right? So I can see, for example, that what I will use here, like I want to know when the product page talk to reviews, what is on cluster 1, right? Reviews on cluster 1. What is the average, latency in the last 1 minute, right? So last 1 minute I didn't do any request, I have 0, but you will see we will generate some requests and so on. So first of all, I have my metrics in one place. That's my foundation for managing this latency-based failover. Latency-based failover, sorry. The second thing I need is WebAssembly, right? I say I will use WebAssembly because I need the product page service to check what is the latency in a regular basis and take decisions based on that, right? So WebAssembly, what is it? Is like a way for you to build your filters. In Envoy, if you would like to build your filter, normally you would like write them in C++, and that will be very complicated, and you would have to statically link it to Envoy. So you would have to provide your Envoy with your filter and replace the one that comes with Istio, and you would not be able to do that during runtime. So you will have like a lot of these limitations. But with WebAssembly, you don't have these problems anymore, and that's what we are going to do right now. So with WebAssembly, you can write filter in any language. When we say any language, it's any language that can be compiled into WebAssembly binary. And we provide all the tooling with the Gloo mesh command line that's called meshctl to allow you to build and publish and deploy all these filters. So you don't need, let's say you want to use like assembly script or TinyGo, then you don't need to even deploy this language in your laptop. You just like do create like the skeleton of your filters through meshctl. You write your logic right in the code, and then when you build it, meshctl will use like a Docker image with that has all the dependencies to build it, and then you can publish it in what we call a WebAssembly hub, or you could use also like a local registry. But with the WebAssembly hub, it's very easy to start experiencing with WebAssembly. So you will see, very nice, we have this tooling, but we also have like a declarative way to deploy your WebAssembly filters, and that's what we will use in the demo. So this locality-based failover, we will have like the WebAssembly filter running attached to the product page Envoy, and it will regularly send requests to the Prometheus instance running in the management plane, where we have all the metrics of all the pods and all the clusters. And based on that, it will determine if this access to the local review service becomes slow. And if it becomes slow, then it will add a header that we will use to redirect the traffic to reviews on the other cluster. Okay, so first of all, what we need to do is that we need to make this product page able to talk to the local reviews again by removing the patch we did before. So that we'll restart it, and then we should soon be able to reach out the service locally. Okay, so we are like in a normal state where we just communicate with the local services, right? then we will have to do a few things, right? So let me just show you what we are going to use. So we will have like this destination we will create that will allow Gloo Mesh to create like a service entry, and Istio will use this service entry to let Envoy know how to contact promoters. And also we are going to create this WASM deployment. So in a declarative way, I want to use this image that I built that needs some parameters, right? And it uses this parameter like interval to know when it should contact Prometheus. So it will be like every 1 second. As you can see, it will contact Prometheus with this cluster name, and it will run this query, and I will show you that in the Prometheus UI. But basically it's like checking the latency, the average latency when product page talk to reviews, and if the average in the last minute becomes greater than 100 milliseconds, then it creates a header called cluster with the value cluster 2. Otherwise it will be the value cluster 1. And finally we will keep the virtual destination like we had before. We will keep the traffic policy to make it transparent, so that if it cannot contact the local one, it will go to the other cluster. But we will create another traffic policy that says if there is like a header cluster equal cluster 2, then I want to send all my traffic to the v3 on cluster 2. So I will be able to see it quickly because it will be like the red stars. And finally I will use another traffic policy, last one, where I will inject a delay of 1 second when product page talk to reviews in cluster 1, right? Okay, so let's apply all these objects. So we'll start with the destination to make Prometheus available. Then we are going to create the WASM deployment, which will be attached like without having to restart the pods. And then we add this traffic policy to send the request to v3 on cluster 2 if I have this header cluster equal cluster 2. And finally we are going to add a delay. Good. So now we can go back there, and you can see I have this delay here that is, you see, 1 second is added whenever I refresh the page. I see it's always take like 1 second more than usual, right? Oh, and you see it switched to v3, which is good because basically that means that my average is now greater than 100 milliseconds, right? And after some time, 1 minute, it will become 0, right? Because we don't send requests to the local cluster anymore, and it will try again to go to the first cluster. It's just an example, right? You could build your own logic. You could use any metric to decide what to do. Even you could use application metrics, right? So I hope it was like interesting for you. You've seen like the power of WebAssembly, especially when you combine them, the WebAssembly and the matrix. And also the idea was to show you like the advantages of using Gloo Mesh in this context, right? To be able to get this locality based failover that I demonstrated first, and then to be able to easily deploy or even build and then deploy WebAssembly filters, the advantage you get also with all these metrics consolidated and so on. So we hope to see you on Slack to continue the conversation. Thank you for watching.